Hello and welcome to another episode of Late Night in Code. This is our first episode in which we're going to be solving a problem. Now, the problems I'm going to start with actually come from the most recent 2022-2023 Southeast Regional Contest. Now, this Southeast Regional Contest, it was used to qualify college students in North America for the national contest. It was competed in by Southeast as well as South Central. And so I'm actually part of the South Central region. So the teams I coach participate in that regional contest. That contest is broken up into two divisions, Div 1 and Div 2, where Div 1 is intended to qualify people for the national contest, and Div 2 is meant to be an introductory contest for people who are either freshmen or sophomores or have never competed in ICPC before. So it's a way to kind of help ease them into what ICPC is. And this one is called Fading Wind. It is the easiest problem from that regional contest. It was included in both Div 1 and Div 2. On Caddis currently it's rated about a 1.4. So I figure we're going to try to solve all of these. Might as well start with the easiest ones. So here we are. You'll note that this one is by far the easiest because it also tells you exactly how to solve it. But hey, if we're going to start somewhere, right? So let's go through the problem. Fading wind. You are competing in an outdoor paper airplane flying contest and you want to predict how far your paper airplane will fly. Your design has a fixed factor k such that the airplane's velocity is at least k, it will rise. If its velocity is less than k, it will descend. Here's how your paper airplane will fly. You start by throwing your paper airplane with a horizontal velocity of v at a height of h. There's an external wind blowing with a strength of s. With h greater than 0, repeat the following sequence. Increase v by s, then decrease v by the maximum of 1 or v over 10 floor of. Note that the floor of v over 10 is the value of v over 10 rounded down to the nearest integer if it is not an integer. Then if v is greater than or equal to k, increase h by 1. Then if 0 is less than v less than k, decrease h by 1. If h is 0 after the decrease, set v to 0. Then if v is less than or equal to 0, set h to 0 and v to 0. Then your airplane now travels horizontally by v units. Then if s is greater than 0, decrease it by 1. Compute how far the paper airplane travels horizontally. The input given is a single line containing four integers, h, k, v, and s, which can go up to 1,000. A is the starting height, k is a fixed factor, v is the starting velocity, s is the strength of the wind, and we need to output a single integer, which is the distance our paper airplane travels horizontally, and it can be shown it's always an integer. Okay, so a pretty straightforward problem, and all we're essentially going to do is take in our input and then just follow these steps and produce the desired output. So with that, let's go ahead and jump over to our terminal here. I already have it set up in Zellij with my Rusty Solutions branch. If you're not really sure how this has been set up, I have a video for you on how I configured this. But the basic thing here is that inside this branch, everything's going to be included in a cargo project. So I'm going to go ahead and open up our project here. And then I'm going to go ahead and real quick FF into mod RS. And then I'm also going to go ahead and open this up, and we're just going to add here an ICPC and then see this into that directory. I didn't realize it couldn't copy over, so then that's ICPC SE Reg 22 Fading Wind. There we go. And that should, yes, that opens it up. So I can go ahead and open this up now. Perfect. And then let's go over here. And so then now to go ahead and include this as a part of the cargo project, all I have to do is then say mod ICPC hub mod SE Reg 22 hub mod fading wind. And now I can go over here and say fading wind maps to ICPC turbo SE Reg 22. Oops, I put a Q up here. Let me go ahead and 5K. There we go. And then 6J, perfect. And then we'll say fading wind and then turbo into main. And there we go. So that's basically all we have to do. Like I said, it's a little bit of overhead, but it's not too bad. And now we can actually just include all these in our cargo project. Then we'll go back to fading wind. And then now we can actually start setting up our solution. And so let's go ahead and look real quick at our inputs. As it said, it's going to go ahead and give us a single line with HKV and S. So we're going to say let tuple HKVS be equal to the evaluation of this block. We're in this block, we're going to say let mute buffer because we're going to have a string buffer. So this is a new string, and the string buffer is going to be what accepts our command or our standard input. So to get our standard input, we say IO, turbo standard in, then read line, passing in a mutable reference to that buffer. This is going to return a result. The result will either error if there is an IO exception or return the number of bytes read. So if we unwrap that result, then it will throw the error or just move along. So then the next thing that we can go ahead and do is we can go ahead and collect all of these into a vector. So I can go ahead and say let params, which is going to be a vector of i32s, now be equal to the buffer. And then we'll say .trim .split on space. That's going to return an iterator. So I can map over that iterator for every param in that iterator. I can say s.parse into i32, which is the 32-bit integer type, right? And then that's also going to return a result, either a number format error or the actual i32. So we can also say unwrap on that. Now in this particular case, it will actually throw that error or give us the i32. And then we can go ahead and collect. And so now params is a vec of i32. And then we can return a tuple with params 0, params 1, params 2, and params 3. We're not going to put a semicolon. In Rust, if you put a semicolon, then you actually turn the statement, well, you turn the line into a statement. So the way to say this is in Rust, everything's an expression. So if you put a semicolon, you take the expression and you make it a statement. If we leave it off, it's still an expression. So that means that the evaluation of this block will be the result of the last expression. So since this is the last expression, this will be evaluated as a tuple, and then we'll deconstruct that tuple into HKVNS, and that's essentially how this works. So then now we can go and semicolon that. And real quick, I'm going to go ahead and check and see which variables are mutable. So we can increase V, we can decrease H, we can decrease S. So those are all mutable. So that means that H is mute, V is mute, and S is mute, but K is not. Okay. So now we're going to follow the instructions. It says while, so we're going to do a while loop, H is greater than 0. Repeat the following. First, increase V by S, V plus equal S. Then decrease V by the maximum, so V minus equal the CMP max of 1, and then the floor of V over 10. Well, V and 10 are both i32s, so V divided by 10 will actually produce integer division, which always uses the floor anyway. So that'll be fine for us. Now we don't currently have CMP here, so we'll go ahead and include the CMP crate. There we go. And now we're good. Next thing is if V is greater than or equal to K. So if V greater than or equal to K, then increase H by 1, so plus equal 1. There's no increment operator here. If 0 less than V and V less than K, we decrease H by 1, so minus equal 1. And if H is 0, so H equals 0, then we set V to 0. Yep, we set V to 0. After that, if V is less than or equal to 0, then we are going to set H to 0 and V to 0. Okay, now we're going to travel horizontally. So let's go ahead and move up real quick. And we need to say let mute H dist be equal to 0. And then we'll go back down. And now we can say H dist plus equal to V. Good. And then if S greater than 0, S minus equal to 1. And then after we're done with this loop, we're just going to print line. And we're just going to print line that H distance. And that's basically all we need. Okay. So then the next thing is I would like to go ahead and try this. So if I Alt P, sorry, let's see if how do I do this? Is it Control P? Control P and then W produces a floating frame, and I can go ahead and enlarge that. It's so cool. And then now what I should be able to do is I should be able to say cargo run dash dash, and then I can say dash S fading wind. And I can say 1, 1, 1, 1, which I believe is the first sample test case. Yep. And then we should get a 1. Perfect. And then now if I want to go ahead and test this, we can say /quest here. And then if I say dash dash help, it gives me the uses instructions, which just means that I need to give it a solution. So let's go ahead and get that data. We'll go to sirjudging.vanby.org, which has all of the data. I can download that data. Download it. Okay, there it goes. So then I'm going to go ahead and mv mnt, yep, C users, my username, downloads, data, 116 into here. And then I'm going to go ahead and unzip data 116, clear that, and then MV the data into tests, fading winds. And then I'm going to go ahead and remove the zip. And it should be the case that that's ignored. Yes, so it will be ignored. And now I can go ahead and quest into fading winds. And there we go. And so again, if you haven't seen that build video, I found out the group of vowels is called a parliament of vowels. So I've gone ahead and set up this as a like kind of parliamentary procedure. So whenever we would try to test something, we open the question, which has to be voted on. So then each test case is voting aye or nay, depending on whether or not it passes or fails. And if all of them vote aye, then it passes. If anyone votes nay, it vetoes. So there we go. And so now we've actually passed all of these. And so with that, we can go ahead and come into fading wind, and we will submit that. Now, I've already submitted these before in Rust. At least a few of these I submitted before, just as a part of like trying things out for this channel. And there we go. All 54 solutions passed, just as we expected. And with that, we've now solved our very first ICPC problem in Rust. So hope that you enjoyed this, and looking forward to the next video. I certainly am. But until then, have a great night, and I'll see you in the next one.